Hi everyone, welcome to another session of the meetups of Decentralized online, of course. So it has been kind of like a long time since the last one. We have been working on other stuff, other events. I will announce soon. And today we're back with Alberto from Moonbeam. And yeah, he's gonna present about the project, how it works. It's gonna have a little of technical content, but also like basic content. So I think we will cover everyone. If you have any questions, just remember you can use the chat at any time and he will answer your questions. And also down below, there's kind of like a box, so you can use both to ask anything. And also we'll have another meetup coming up probably like early next month, and then we'll take a break in August because yeah, everyone is not like going to come. So yeah, I think that's it. So yeah, Alberto, all yours.
Thank you, Sylvia, and thank you for the invitation as well. It's super exciting to be here. Thanks everyone for tuning in. My name is Alberto. I work for PureStake, which is the company building Moonbeam. And today I have a brief presentation for you about the project, how it works. We're going to go a little bit technical, but not too deep. And I'm super happy to answer any questions you guys might have. As she mentioned, put it on the chat, put it on the Ask a Question button, and I'm super happy and super excited to answer any questions. So with that, let me share my screen. And let's start with the presentation. Oh, by the way, I'm actually gonna post the links to the slides in case you wanna look them over. So this is the link. And so yeah, I guess the name of the presentation, it's Moonbeam and Ethereum-compatible environment on Polkadot/Kusama. So everything that I'll be saying here today, it's actually valid for both Polkadot and Kusama, all right? So a little bit about myself. My name is Alberto. Oh, there we go. My name is Alberto. I'm the developer relations manager at PureStake, which is the company building Moonbeam. You have my GitHub handle, my Twitter handle, and my email from the company. I am actually a mechanical engineer. I studied mechanical engineering in Venezuela. I did a master's and PhD in internal combustion engines in Valencia, Spain. But I've been always very passionate about blockchain since like 2013. I really like to read about how the protocol works and how like everything works on the back. And I started working at PureStake a little over a year now, and it has been quite a ride. And I'm super excited about this space in general. So yeah, that's a little bit, like 10-second introduction about myself. So let's go over the session structure, right? So I know that you guys had a session on Polkadot, but I just want to touch really quickly about some Polkadot concepts and some architecture, because it's all gonna merge together into what is Moonbeam and what's the purpose of Moonbeam, right? So the next topic is going to be a little bit about Ethereum, what is gas, and the current problems that Ethereum has. And then we're going to merge these 2 points into Moonbeam, what is Moonbeam, and multi-chain on Polkadot. So I guess let's just go ahead and start with the first topic, which is what is Polkadot, right? And this is going to be like a 2-minute introduction to Polkadot. So this is not perfect in any sense. So, it's like there's a lot of content out there. I just want to make sure that there's some information that you understand about Polkadot that is going to help me tell the story about Moonbeam. So Polkadot or Kusama allows for interoperability of chains or blockchains, right? And the basic architecture is this. So Polkadot or Kusama, you can see them, they're a blockchain, right? And you can see them as a ring in the middle that has certain like slots or positions for other blockchains to connect to. Right, and the main thing about the relay chain, this blockchain is called the relay chain. It provides shared security and it's able to pass messages between blockchains. So the main selling point of Polkadot or Kusama is that blockchains that connect to it will be able to communicate or interact with each other natively. And this natively, it's a key point there, right? Because right now, Bitcoin and Ethereum can communicate with each other allegedly, but they're using bridging mechanisms or centralized entities, right? So it's very different, these solutions, that a native interoperability solution such as Polkadot and Kusama. So parachains are basically independent blockchains that connect to the relay chain for continuous block finalization. So Polkadot and Kusama's architecture, it's very weird, it's very different because for these kind of blockchains, there's block production on one side, and block finalization, what says that this block is valid on another side. And that's basically the two roles that there is in Polkadot. Parachains propose blocks, and the relay chain, in this case, Polkadot or Kusama, tell which block is valid and which is not. And last but not least, we have parathreads, which are very similar to parachains, but they pay for block-to-block finalization compared to the parachains, which are continuously connected to the relay chain, right? So when a parathread has a block with transactions that they want to finalize, they want to make sure that it's valid, they will send it to the relay chain, make a bid for it, and then it'll just like finalize it, and it can be added to the blockchain. So let's go briefly once again into a basic parachain structure, right? So parachains are independent blockchains inside the Polkadot and Kusama ecosystems, like I mentioned, and it has coallators, which are like similar to miners in Ethereum, but it's not exactly the same. So they're represented by these dots on the right-hand side, and they basically produce blocks with valid state transitions. So you might have heard this term quite a bit in the world, like state transitions, valid state transitions. And in simple terms, it's basically this, right? So a state is basically, let's say, the account state. So you have Alice, Bob, and Charlie, and they have a certain balance, right? Let's say Alice has 10 tokens, and she transfers 5 tokens to Bob. So a valid state transition would be that in the next block, but Alice will have 5 less tokens, and Bob will have 5 more tokens, right? So coallators have to produce blocks with valid state transitions. Parachains need to have an economic model which is sustainable, meaning that they will need to connect to the relay chain, and they'll have to pay a bond or deposit a bond to do so. So they have to find a way to make this system sustainable long term, because if they're not connected to the relay chain, they can basically work. And they connect to what is known as a slot in the relay chain, and that is what allows them to have block finalization, right? So more or less, this sketch or the diagram would be that coallators will propose blocks to the relay chain, which is basically this pink and this 3 strips, which are the validators, the entities in the relay chain that will check for these blocks. So the validators will grab it, make sure that the state transition is valid, and then this block can be like appended to the blockchain itself. So I don't know if you've been like into the Polkadot or the Kusama news like lately. I'm talking in the past like 2 weeks. We're right now June 15th, in case you see this in the future. But it has been pretty wild and pretty crazy this past 2 weeks, because the parachain slot auctions started actually today. And there's a lot of news regarding crowd loans. So basically, slot auctions is how parachain slots are distributed on the relay chain. So it is a mechanism called candle auction, which basically it's a regular kind of auction that after it ends, you pick a random point back in time and you choose the highest bid at that moment. So it's not when the auction ends, but it's a random point back in time and you check for the bids at that moment. Crowd loans are making a lot of fuss in the headlines because it's a way for projects to crowdfund their bid for a parachain slot auction, right? So we're working on Moonbeam and Moonriver. Moonriver is the Moonbeam implementation in Kusama, and the Moonbeam Foundation is actually hosting a crowd loan to bid for the parachain slot auction. And if you have KSMs and you're interested, you have 2 links on the right-hand side. But this is super exciting, the moment we're living, because it's basically like writing history and the Kusama ecosystem. And projects can actually do direct bids as well. If they have enough KSMs, they can just say, I'm going to pay for this slot. I'm going to bid for this slot myself. They don't need to crowd loan their contributions, right? So this was basically, a very brief introduction into Polkadot and Kusama ecosystem. Now we're going to go ahead and talk about Ethereum once again, super brief. So we're going to talk specifically about gas and about the current problems that Ethereum has. So before we understand Ethereum, let's roll back and understand what is the EVM and at a very high level. Basically, the EVM is a virtual computer that processes Ethereum transactions. It is able to execute operations, and these are related to smart contracts and transactions. It is sort of decentralized because each node in the Ethereum network, and we're talking about miners all over the world and full nodes, has their own EVM, right? So they can verify with their EVM that all the transactions and the operations are valid. And it actually, the EVM costs, operating with the EVM has a cost. And this is what we're going to refer to as paying for transaction fees. It's basically because the EVM has to process that transaction. So these are like the 3 topics that you need to understand with the EVM. It's basically a virtual computer that is all around the world, and it costs, basically you have to pay to operate in that computer. So gas is another term that we hear like all over the place, right? Like, oh, gas prices are so expensive on Ethereum. Oh, it is so expensive to trade in Uniswap on Ethereum or whatever. And basically gas is the unit that is used to pay for EVM execution. So this is a misconception that people have, that they think that to execute on the EVM, you have to pay ETH or Ethereum, and you don't. You have to pay its gas, all right? So basically, each operation that we do on the EVM has a gas value associated to it. So let's say we want to add 2 numbers, we will have to pay, for example, 10 units of gas, which is not the case, but it's just an example. So the gas price per operation, it's fixed, but the amount of ETH that you pay for each unit of gas, it's not. And that's like the problem. So the gas price, what's called the gas price, is the amount of ETH we pay for each unit of gas. And that actually fluctuates depending on how constrained the Ethereum network is. And basically, this means that the more you're willing to pay for a unit of gas, the higher priority your transactions will have. And to illustrate this, I brought an example on the right-hand side of the slide. And basically, let's say this is like my own Ethereum network that I have running in this PowerPoint presentation or whatever. And it has an EVM that it's only able to process 1 transaction per block. And we have these 5 transactions at the top. So it's not a very high performant blockchain, but for the purpose of this presentation, we'll do. So this blue transaction here, this guy is paying 5 times more Ethereum per unit of gas than the gray transaction, right? So from an economics perspective, if I'm the miner mining that operation or processing that transaction, it'll make a lot more sense for me to process this blue one, because I'll get 5 times more reward, right, than if I do the gray transaction. And it just makes more economic sense. So I will probably just process the blue one first, then I will go with the magenta one, then I will do the yellow one, the purple one, and last but not least, the gray one. This is, of course, if there's no other transactions coming into my blockchain, right? So if I only have these 5 transactions, I will do, in this order, I will do them per block. And this is the problem, right? So basically, Ethereum poor scalability it's just equals to high cost, because it's just become too expensive to operate on Ethereum. Lots of projects means lots of user adoptions, which consequently means lots of transactions. So when we have lots of transactions, then people are willing to pay more for their transaction to go through. This means that if my transaction is important, I'll pay more ETH per gas than other users, and then my transaction will get included faster. And just as a reference, on the right-hand side, I brought some data from EtherScan. This is the transaction fee and Ether per day, I think, that people have paid, right? So you can see here how we're roughly reaching like 20K, so 20,000 Ethereums per day on transaction fees. It's just crazy the amount of transaction fees that people are paying on Ethereum, right? So we talked about Polkadot, and we talked about how Polkadot allows natively to communicate with other blockchains. And we talked about the problem that people are having on Ethereum due to the high gas fees, right? High gas costs, let's say. So with that in mind, what is Moonbeam? So Moonbeam is an Ethereum-compatible smart contract platform on the Polkadot and Kusama ecosystem. Like I mentioned before, on Kusama, it's Moonriver. So basically, Moonbeam works with everything that you need in regards to Ethereum existing tools, dApps, protocols. So we're solely focused on providing a seamless and frictionless Ethereum experience, but on the Polkadot ecosystem. And we're going to see this in the demo that I brought for you guys later on. So this means that we have, you can use Ethereum-based tools such as MetaMask, Remix, Truffle. You can deploy Solidity smart contracts or anything that compiles to EVM bytecode. And the important thing to understand is that we just didn't add like an EVM compatibility layer but we have actually developed other like technology stacks on top of that to provide the best Ethereum experience possible on the Polkadot and Kusama ecosystem. So something that I really like to say to other projects is, it might sound like cliche or something, is that if you're an Ethereum developer and you're trying out Moonbeam and you hit like a roadblock or a barrier, that you found something that it's not as as it is on Ethereum, we're not doing that job right. And it might sound like a little bit idealistic, but that's what we're trying to achieve. That's what we're aiming for, right? So with that in mind, a lot of projects basically see Moonbeam as a platform where they can either, if you were phased out of Ethereum because of the current gas price, Moonbeam might be a cheaper alternative for you to deploy your project or your contracts, right? But on the other hand, we've also had a lot of partners which they just want to stay on Ethereum, but they just want to enter what is known as a multi-chain future, right? So we believe on the multi-chain future, meaning that there'll be multiple blockchains in the future, and then they'll just be there and they'll just provide different features, and Moonbeam will be one of them, right? So with that in mind, this is how we envision the multi-chain future. And it's basically if you have Solidity smart contracts or anything that is Ethereum related and you've deployed those contracts to Ethereum, you can actually just grab that same project structure, and if you use, for example, Truffle or Hardhat, just change the network. Instead of deploying everything to Ethereum, I want to deploy this to Moonbeam, and it is just that simple. And we're truly excited about the ecosystem, or like the ton of projects, partnerships and projects that have announced that they're working on Moonbeam deployments. It has been kind of like a core object, like an idea that we've been pushing for, is like bringing like a very rich ecosystem of multiple projects that they offer different things, because it is truly what it brings value to this project, right? So we have SushiSwap, Balancer, Ocean Protocol, ChainSafe. We have Chainlink, Human Protocol, and other. You can find more projects and the link that I put on the slide. But it is truly amazing, the ecosystem that we've built inside the Moonbeam network. So how do we bring Ethereum compatibility to a substrate-based chain? And I've not mentioned Substrate before, but basically Moonbeam is built on a different technology stack that what it is used on Ethereum. So Ethereum uses something called Geth, or Go Ethereum. And basically Moonbeam is built on Substrate, which is Rust-based. So it's another completely different like programming language, right? So this section explains a little bit of how we achieve these Ethereum compatibility features. And it's all very high level, like I mentioned before. So let's say you're an Ethereum user and developer, and you're using your regular Ethereum tools such as MetaMask, or we're probably familiar with MetaMask, but other tools such as Remix, Hardhat, and Truffle. How you communicate with your Ethereum node is basically it's what it's known as JSON RPCs. So basically, these tools will make a request to the Ethereum node, and the Ethereum node will provide a response. And that's the main idea of how you communicate with an Ethereum node. You send a request, and then you get a response, right? So for example, if MetaMask needs to have your account's balance, it will ask the node, hey, what is this account's balance? And then the node will respond in a JSON object, and then you can decode it from there. What happens on Moonbeam is that we implemented a project that we helped develop, and we got a Web3 Foundation grant for our help in this Frontier project. It is called Frontier, right? And the best definition that I like to give to Frontier is the black box definition. Basically, the idea is that Frontier is kind of like a middleman, like a translator that will translate Ethereum language to Substrate language. But from the perspective of the Ethereum user or developer, nothing has to change. Nothing will change. You will do exactly what you do on Ethereum, but then Frontier will do all the hard work for you, and Moonbeam will be on the other side of things, just getting receiving your transactions and processing them and so on. And that's really powerful, because the idea is that users will not leave the Ethereum world that they already know and they're familiar with. So this is a lot of technical jibber jabber. What does this mean, right? So what's the in practical terms, what does this represent? So This is basically what it's called, the ETH JSON RPC. This is how, like I mentioned before, that you make a request and then you get a response. And what this code snippet shows is that we're making a request to our testnet, which is called the Moonbase Alpha testnet. And we're actually telling them, hey, testnet, we want to get the balance. This is a regular Ethereum method. This is nothing that is specific of Moonbeam. This is something that you can do on Ethereum as well. We want to get the balance of this account in the latest block that you have possible, right? And when you do that against our testnet, you will get this response, which is exactly the same response that you will get on Ethereum. And this actually, it's a number, but if you decode it from hex and you pass it to, from way to regular units, Ethereum units, you will get basically that this means that account had 49.95 dev tokens. And if you, check MetaMask, you will have in this case, 49.95 tokens. So this is what I mean, that you will be able to use MetaMask because MetaMask will ask this kind of questions to a Moonbeam node, and it'll get the response that it expects, right? And like understanding this is kind of mind blowing because it tells you that you don't have to worry about anything. And in the demo, you will see that everything will be more or less familiar. So one important topic that makes Moonbeam basically different than any other parachain project out there offering Ethereum compatibility is unified accounts. And I want to explain it really briefly because it is an important kind of topic in this world. So unified accounts is something that Moonbeam introduced to basically simplify the accounting system of this like Ethereum compatible blockchains. Sorry. So basically how Substrate works is that Substrate is kind of like it's a tool to build blockchains that work with like Lego blocks, right? So let's say you want to add like balances to your blockchain, then you will add what is called the balance palette. If you want to add like Ethereum compatibility, you will add like a couple of Lego blocks that give you Ethereum compatibility, right? So basically, any blockchain, any Substrate blockchain that uses the EVM palette and the Ethereum palette and Frontier, so these are like the Lego blocks that I was mentioning before, will offer Ethereum compatibility, right? And you might ask, hey, like, what's the point? I can just grab my own blockchain, then I can just be Ethereum compatible, and that's it. So let me, this diagram looks a little bit complicated, but let me take you through it because it's not that complicated, right? So in a Substrate blockchain, you will have what is called the Ethereum API, or like the Ethereum experience, and the Substrate experience. The Substrate experience is everything related to how you communicate with a regular Substrate node. And the Ethereum API is what we showed before. It's like how you would communicate with a regular Ethereum node. So let's say a user, let's call her Alice, right? She wants to interact with the Ethereum side of things. So she wants to deploy a smart contract. So if you're familiar with like private keys and signing transactions, she'll need a private key that is associated to an H160 address. And H160 addresses are Ethereum addresses, right? So she'll have to have a public account and a private key that is Ethereum compatible to sign everything related to the Ethereum experience or the Ethereum side of things, right? This is smart contracts, transactions, or check her balance. And this combination can be mapped into Polkadot or Kusama styled addresses, which is called H256. So they use different addresses or account systems, right? The problem is that Alice doesn't know the private key of this account, of this address, right? She only knows the private key of her Ethereum address. So she cannot sign transactions with this H256 address, meaning that she can only do read operations. So it's stuff that doesn't require you to sign a transaction. So like check your balance, for example. If she wants to interact with the Substrate world or the Substrate side of things, for example, to do governance or staking, she'll need another account with another private key and another address so she can sign messages related to that side of things, right? So the same user needs two accounts to interact with both worlds of the Substrate blockchain. What Moonbeam did is basically just scrap all that. This is too complicated. This doesn't make sense. And just unified all the account systems. So everything related to Substrate and to our Ethereum implementation works with your regular Ethereum private key and H160 address. And this is truly magic, right? Because it's just simplified. This diagram looks a lot simpler than the other one, right? And it's just because you only have to have one account to basically work with everything. And it's just a lot simpler. So hopefully this helped you a little bit to understand one of the core benefits that Moonbeam offers in terms of Ethereum compatibility. So I've talked enough. Let's do a short demo first to show you around, how Moonbeam feels, how you can deploy a smart contract, and how you can interact with it, right? So I told you a lot about how interacting with Moonbeam, it is just exactly as interacting with Ethereum, right? So one of the most common tools out there is MetaMask. So let's say I have MetaMask connected to the Kovan testnet, and in here you can see that I have some Kovan ETH and I have some ERC20 tokens. And you might ask yourself, okay, let's connect MetaMask to Moonbeam. So we do have a testnet called Moonbase Alpha, and to connect MetaMask to Moonbase Alpha, there are two ways of doing it: the easy way or the hard way. Let's do the hard way first. You will click here and go into settings, go into networks, and then you have to add a network. Once you add a network, you'll have to fill up this information that I've pre-filled here, so you can see. And this is all in our tutorials website, and I'll show you in a bit. Right? So once you do this and you click save, MetaMask will automatically connect to the testnet, and that's it. You have exactly the same experience, exactly the same kind of interface, but you're connected to a different blockchain, which it's amazing, right? Because you're using exactly the same Ethereum experience that you're used to. So in here, you can do what you would expect. You can send tokens from Alice to Bob. You can add an ERC20 token down here and just add the contract and the symbol and everything. So actually, let's go ahead and do that. Let's deploy an ERC20 smart contract to the Moonbase Alpha testnet and check it out. So if you're not familiar with Remix, it's an online tool to compile and deploy Ethereum smart contracts. It is like a very cool way to get started with the Ethereum side of things because it's all web-based. You need to download anything, and it's super helpful to get started. So what I have here, it's an ERC20 smart contract. So ERC20 is a token standard, and it basically you can see that I'm using open separating contracts, which is the standard in the industry. And I'm going to create a token called Kalum Labs, and the symbol is going to be C Labs or Claps. And what I'm going to do is that I'm going to mint 1 million tokens, right? So you can see that my contract is already compiled, as you can see. And in the deploy and bronze transaction, I'm going to connect to Moonbase Alpha, the testnet, by clicking on Injected Web3. And you can see that I'm using the 1287 chain ID, which is the Moonbase Alpha chain ID. Oh, by the way, I totally forgot that I told you there was an easy way to connect MetaMask to the testnet. And it's basically by visiting our documentation site, which is docs.moonbeam.network. I'll put it here. And you can click this button, Connect MetaMask. It is just that simple. Once you connect it, you'll have a pop-up saying, hey, are you sure you want to connect MetaMask to this, to this? And basically that it is that simple. All right, with MetaMask connected to the testnet, you can go ahead and deploy this contract. And I'll just click here, Deploy. And you will see a MetaMask pop-up as you would on regular Ethereum, telling you the gas price and the gas limit. And I'm just going to confirm this transaction. And once the contract is deployed, we will actually see the contract down here, and we can interact with it. Or we can go ahead and copy the contract address to MetaMask and interact with it from there, right? So you can see that I have the contract address. I'm going to go ahead to MetaMask, add token, and I'm going to add my newly deployed ERC20 token that I just basically deployed on the Moonbase Alpha testnet. And it's just that simple, right? I can go ahead and transfer some tokens to Bob. Let's transfer 100 tokens. And this is, how it would be if you're transferring, let's say, Link tokens or whatever other ERC20 token you might have had in your MetaMask wallet. And it is what, like I mentioned, everything should feel very Ethereum-like because that's the experience that we want to provide to developers and to users as well. All right, so I can go ahead and go to Bob's address, and I'll just add this asset here. And Bob has 100 CLabs tokens, right? Cool. If you have any questions, make sure you put them on the chat or click on the Ask a Question button. I'm happy to answer any questions you might have. All right, so if you want to know, if you're a developer and want to know how to get started on Moonbeam, you basically have two ways. So let me put percent here. You can either build your own development node, which is like super fast because it is like Ganache, which is like it will produce a block every time there is a transaction. So you don't have to wait for like 17 or 12 seconds or 14 seconds for every block. It'll just be like super fast. And to build a development node, you have either Docker. We have a Docker image with a pre-built binary. And you can also clone the repo, compile the binary, and run it in dev mode. So you have two ways, a faster way, which is Docker, and a more slower way that is cloning the repo and compiling the binary yourself. But in any case, I would say the best way to get started was with our testnet, Moonbase Alpha, because as you saw in my previous example, it is very fast to get started, very straightforward. You have HTTP and WebSocket endpoints. You have a token faucet on Discord where you can get free dev tokens. They're not worth anything, but you can use them for playing around. You also have staking and governance features, which is something that it's unique of Moonbeam, right? So Ethereum doesn't have staking for now, doesn't have any governance. That will be something that it's implemented on Moonbeam natively, right? Just some more like information regarding how you can get started with the development node. You have like the way that you run the Docker command to get a development node running quite fast. You also have how you can clone the repo and get started with your own local node, and some extra flags down here. I just put the slides in case in the future you want to check them out. I'm not going to go through them all because it's just a lot of information to digest, right? In case of the testnet, you also have like the HTTP and WebSocket endpoint. And this is very useful because if you are a developer and you use Web3 JavaScript, Ether.js, Truffle, or Hardhat, you can define your Web3 providers in different ways, basically using this HTTP endpoint, for example, right? So you can just, like, for example, grab your project that you have on Truffle and just add a Moonbase Alpha provider, as you see here, and it should work pretty much right away. It is truly powerful. So there's a question from CG. Does Moonriver work the same way? Yeah, exactly, 100%. So Moonbase Alpha is a testnet, and the idea is to test everything that then will port to Moonriver and Moonbeam, right? So Moonriver is in the process of the crowd loan and getting onboarded to the Kusama network. But in the future, the idea is that you will be able to interact with Moonriver, which is a mainnet launch on Kusama, as you would on Ethereum, right? And there are some differences because, like I mentioned before, you have governance, you have staking. So there will be some slight differences, but as a whole, for example, let's say we have Balancer deployed to Moonbeam. Well, actually, I'm going to show you a nice demo, so I won't ruin that demo for you. So, oh, actually, this is the slide, and it's just on point for your question. So I did bring some example DApps, and we have some like DApps running on Moonbeam on our testnet Moonbase Alpha, just to show you the power of Moonbeam in this sort of like applications, right? So the first application that you can test, and I'm going to actually put this link, couple link address. This is an application where you can like mint ERC20 tokens that you will then be able to use on other applications that we have running in our testnet. So I'll show you how to do this, but it's you can find the link here. The next application, it's basically a let me paste this in here. It's a Uniswap v2 clone that we have running in our testnet just to prove how Ethereum compatible we are, right? So if you're familiar with Uniswap, you'll be able to add liquidity, create your own pool, swap tokens. Everything is running just to show, showcase that Uniswap v2 is able to run on our testnet Moonbase Alpha. And last but not least, we have a Moonlink dashboard. So basically, it's a Chainlink implementation. Oh, I'm making a mess. There it is. basically it's a Chainlink implementation of their oracles on our testnet, and it's a dashboard where you can see like prices and everything regarding to Chainlink, which is it's actually pretty cool. So basically, let's start with the Minter app, right? So let's say you open this this app. You're already connected to Moonbase Alpha by clicking this button in the documentation side, and you want to mint some ERC20 tokens. So let's say I want to mint some Venus tokens, right? So I can just go ahead and I have 0. As you can see, my account doesn't have any Venus tokens. So I can just go down here, select Venus from the drop-down menu, and just click submit. And this is going to submit a MetaMask transaction. By the way, this just looks weird because I'm like super zoomed in. I'm just going to confirm this transaction. And once this transaction is confirmed, you will see that I'll have 100 Venus tokens. And I'm only able to mint once every hour. So this Boolean will be set to false, telling me that, hey, you already minted. You have to wait for a whole hour in order to mint again. So you can see that I already minted some Mercury tokens just to test this out before the presentation. So let's see if I should already have 100 tokens, but sometimes the dashboard takes a little while to refresh the balance. There we go. So I have 100 and the Boolean is set to false. So go ahead, try it out, see how easy it is to mint tokens. And the cool thing is now you can go to the Uniswap implementation that we have. So this is moonbeam-swap.netlify.app. And in here, you can play around with these ERC20 tokens, right? So I'm going to go ahead and I'm going to put in some Merc tokens, and I'm going to get out some Earth tokens, right? So I have a balance of 1 Merc, and I have 0 of Earth. And I'm going to swap 1 for 0.987158 Earth. So as you would on Uniswap, you will swap, confirm the swap, and you will get a MetaMask pop-up. Then you can confirm. And we can actually see the, oh, wait, no, this is not working. No, it's still not, because we can actually, once the transaction is confirmed, will be visible on the Moonbeam Explorer. But right now, it should not be visible because it has not been processed. But once this transaction goes through, let's see. It's pending. There we go. I got the confirmation. So I should be able to see my Earth balance. As you can see, it's now 0.99. And hopefully this shows up. There we go. So this is Block Scout, which is like an Etherscan kind of block explorer where you can see a lot of information regarding, the transactions. You can see here that I swapped 1 Merc for this amount of Earth tokens and so on. And all this is running in our testnet. Last but not least, we have the Moonlink dashboard. And this is basically, it shows you the price of different tokens in USD. And you can see here, this is the last time they updated. They update every hour, or if the price fluctuates more than 1%. I think those are the parameters that we've set up for Chainlink on the testnet. And down here, you also have what it's called the basic request model, where we can actually request for a price update at this moment. So I can just go ahead and copy this job ID, put it in here, and I'll just submit a transaction. Once again, this takes a little while because we have to submit a transaction. The Chainlink Oracle node needs to fetch the transaction, read the price, and then write it on the smart contract. So this will take a while. We'll probably not wait for this price to update, but in any case, we can check back later and make sure that this price has updated. So before I continue, I just want to take some time to show you our website. This is moonbeam.network. And here you have everything related to basically our project itself. You have Moonbeam and Moonriver. You also have the foundation website where you can find information about the Moonbeam Foundation, everything related to the crowd loan that is happening right now, how you can contribute, how you can participate, how you can, we have a lot of tutorials in there. Well, the foundation has a lot of tutorials in there as well. And in our Moonbeam.network website, you can go ahead and click on this docs link, and that will take you to our documentation site where we have seriously not a million tutorials, but a lot of tutorials in regards, different integrations and examples and applications you can use and so on. So actually, there was a question. Oh, thanks for putting on the chat. I totally dismissed the question. What are the main problems or obstacles Moonbeam may face, and what to fear? Also, Moonriver. Yeah, this is actually a very good question. Thanks, Ivan. So a lot of people ask us, oh, but then when ETH2 comes, you guys are dead, right? Because ETH2 is going to solve the gas problem and so on. So what we like to think of is like the future is going to be multi-chain, right? So even though ETH2 might come in the future, we like to think that we are the gateway for Ethereum projects to access the Polkadot ecosystem. The Polkadot and Kusama ecosystem are very big in terms of market cap, and there are going to be a lot of native assets that are going to live there. So, even though, one of the problems obstacles we may face in the future, it's, the coming of ETH2, we still see a lot of room for us to grow as a project and to basically, continue in the years to come. So, I think one of the challenges that every blockchain project has is how fast-paced this world is, how fast-moving it is, how competitive it is. So, I think this could be one of the problems and challenges where we have a great team working day in and day out to make sure that we are on the bleeding edge of technology and we have everything that we're promising or we're bringing working. And we also have a great ecosystem around Moonbeam. So it's all just, pieces of puzzles that match really well to provide probably a great project for you guys to interact with. So yeah. What I was saying is that in the documentation side, you have a lot of tutorials of how you can get started. If you're a developer, this is probably the way to go, the place to go. And we're also very active on Telegram and Discord in case you have, questions, concerns, everything related to Moonbeam is there. So going back to let's actually go back to the dashboard. And we can see, there we go. We can see that this price was updated basically 2 minutes ago. And this is the Bitcoin price that it's 40,200 at this moment. So pretty cool. So yeah, basically all sounds really good, Alberto. It sounds amazing. Where can I learn more? Like I mentioned before, you can go to our documentation side. We have a lot of content in there for MetaMask, Remix, Truffle and Hardhat, different Ethereum libraries, Web3 JavaScript, Ethers, Web3 Python, how to work with different oracles. We have also a bridge between Brinkiby and Kovan and our testnet. So this is actually pretty exciting that you can transfer ERC20 tokens between Brinkiby or Kovan to our testnet and back and forth. And also NFTs, so non-fungible tokens, ERC721, you can transfer them as well. We have the graph and Covalent running in our testnet, and this is super cool because a lot of projects like Balancer, for example, uses the graph, and we have a lot more content in there. You can learn how to participate in governance, how to stake your tokens. We also have some workshops that are running on a monthly basis, and you can go to our first workshop that will show you how to get started with Moonbeam more on a technical level. So yeah, thanks a lot for tuning in. If you want to get in touch with us, I see that Kathy from our team already put a lot of helpful links out there. If you want to get in touch with us, you can visit our website. We're very active on Twitter, and we'd really love if you follow us on Twitter. This is the two main repositories that we've worked on. Reddit, our documentation site. Telegram is super active. We have an amazing community there. We always try to answer all the questions that people have. It's kind of like a hard task because there's always so many, but we're super friendly and super happy to answer any questions. And we also, for everything related more to developers, we direct them to Discord. We also have a lot of channels there. There are a lot of people like myself truly dedicated to answer any questions you might have. And yeah, I think if there's any other questions, that's a go on my end. I had a lot of time to present all the tutorials, so I'm actually happy.
Okay, guys, if you have any questions, now's the moment. Okay, looks like we don't. So
I might have done a really good job that no one has any questions.
Okay. Yeah. I can share them, Michael. Yes, I can share the slides. Actually, you shared the link, right? Like in the
Yeah,
beginning.
Michael, if you scroll way up in the chat, you should be able to see them, but I'll just copy them and paste them again.
Yeah.
All right.
There you go. Okay, awesome. So yeah, thank you so much, Alberto, for sharing about Moonbeam. And if you guys have any questions, just like join the Discord and you can ask there to the rest of the team. So yeah, thank you so much, and see you
Great.
soon.
Have a nice one. Bye. Happy to be here.